Morning, everyone. I'll be talking about Chapter 7, Experimental, Quasi or Quasi-Experimental and Ex-Post Facto Designs. In the previous video, I talked about the descriptive research design. So for now, we go to Chapter 7. And I have mentioned this one already about one of the things for quantitative research design. No? That this includes experimental, quasi-experimental, and ex post facto designs. In some books, we have also two classifications of experimental designs, the true experimental research designs and the quasi or the quasi-experimental research designs. Experimental studies used to test for cause and effect relationships. So if your focus is on cause and effect relationship, then you go into experimental studies. And in my previous video, I mentioned about correlational study, and it's not actually for cause and effect relationship. It's only for a relationship, but it does not mean about cause and effect. So take note about that caution for correlational studies. Many possible factors might cause or influence a particular condition or phenomenon. You look at a condition, you look at a phenomenon, and you want to find out what are the possible causes of this phenomenon or of this condition. That's why you're going to undergo experimentation. The researcher controls for all influential factors except those possible effects are the focus of the investigation. So we have some controls of the variables involved in the study. As a researcher, you have the control of those different factors involved in the experimental research design. So variables. Variable, as defined earlier, quality or characteristics that has two or more values. Then we classify variable as independent variable and then dependent variable. Independent variable, the researcher studies as possible cause of something else. The researcher directly manipulates. For dependent variable, potentially influenced by or depends on the independent variable. We have the term internal validity in an experimental research design. The extent to which the design of a research study and the data it yields allow the researcher to draw accurate conclusions about cause and effect and other relationships. So experimental designs must be internally valid or the results are not interpretable. So take note about internal validity, one of the things that we consider in experimental research designs. We have also confounding variables. Confounding variables are factors that might account the difference that are not attributable to the particular treatment or intervention being studied. We have the independent variable, we have the dependent variable, but the effects that you can see in the dependent variable cannot be attributed only by the independent variable, but there might be other factors that produce the effects, and that could be accounted by the confounding variables. So we have examples of confounding variables. Two classes use different methods of teaching science. So teaching method, independent variable. Two different teachers, confounding variables. So take note, we have two different teachers, and the teaching method would actually vary. Teachers of different sex, another confounding variable. Why? Because male and female might have some differences in terms of the teaching method. Time of day the class taught, so another confounding variable on whether it is in the morning or in the afternoon, or it might be in the evening. Strategies for controlling confounding variables. Keep some things constant. So example, heterogeneous sample. Include a control group. So normally we have experimental group and then we have the control group. Conduct a double-blind experiment. So participants and individuals administering varying interventions or control conditions are equally in the dark. They do not know about the experiment. So, randomly assign people to groups. In my previous videos, I mentioned already on what is meant by random assignment. Number 5, use one or more pre-tests to assess equivalence before the treatments. So we match the pairs, we match the groups actually. So we look at ito a condition that more or less the experimental group and the control group are actually having equivalence with reference to a certain equating variable. 6, expose participants to all experimental treatments within subjects or repeated measures of the variable. So within subjects must be considered. The repeated measure of the variable must be considered. It should not be done only once, twice, but you have many repetitions to see what you want to see, no, in terms of the effects of the independent variable. Statistic control for confounding variables. So we have partial correlation is used for determining the confounding variable effects. We have the ANCOVA, the analysis of covariance, the standard error of measurement. So the partial correlation, we have the ANCOVA, the SEM. ANCOVA is analysis of covariance, and then SEM is the standard error of measurement. So here in basic research and in basic statistics, you could not actually have that one as topics that you would have better understanding. But in this case, just for introduction, you will learn this one when you undergo higher statistical courses. Remember, a carefully controlled experimental design is the only approach that allows you to draw firm conclusion about cause and effect. Okay. Experimental design. So true experimental designs have a truly independent variable manipulated by the researcher. So we have experimental designs offer control and internal validity. So recall that I mentioned about internal validity in the previous slides. So variations, we have three pre-experimental designs, the quasi or the quasi-experimental designs, we have the ex post facto designs, we have also the factorial designs. So pre-experimental designs differ from experimental designs in that the independent variable does not vary. Experimental uncontrolled groups are not composed of equivalent or randomly selected individuals. So take note, are not composed of equivalent or randomly selected individuals. So if you have experimental uncontrolled groups and assigning people or participants in the experimental uncontrolled are not done in a random perspective, and that experimental uncontrolled groups are not actually having equivalence for some equating variables, then that is part of the pre-experimental designs. Not possible to show cause and effect relationships should be followed by more controlled experiments. So under pre-experimental design, so we have one-shot experimental case study. So we have group 1, then treatment, and then you go to the observation. One group pre-test, post-test design. So you do a pre-test, then you have a post-test. So still group 1, then you do the observation under pre-test, then you give the treatment, and then you do the observation. We have static group comparison. So we have group 1, then you give a treatment, and then the observation. Then you have group 1 also, no observation, no treatment at all, but there is an observation at the end. Through experimental designs, pre-test control group design, pre-test post-test control group design, so random assignment. So we have here random assignment for group 1 and group 2. So recall my discussion about random assignment. And then, so we have group 1 and 2, we have the time, so we have observations. And then in group 1, you give the treatment, and then in group 2, you don't give the treatment, and then you do the observation at the end. So if you give the treatment for group 1, we classify group 1 as the experimental group. We don't give a treatment to group 2, so we classify group 2 as the control group. Then we have also, we have the Solomon, the Solomon four-group design enhances external validity. So we have 4 groups, group 1, group 2, group 3, group 4. And again, we are going to apply random assignment. So participants are randomly selected for group 1, group 2, group 3, and group 4. So group 1 and group 2, you do observations. And then for group 1, you give the treatment, then no treatment for group 2. And then at the end, you go into observations. Then for group 3 and group 4, so no observation at all. And then you give treatment to group 3, and then you no treatment for group 4. And at the end, you do observations. So if you notice, at the end, you have all the observations. But we have a pairing of group 1 and group 2, then group 3 and group 4. Group 1 and group 2 pair, there are observations. Group 3 and group 4, no observations at all at the very beginning. Group 1, you give a treatment, and then group 2, no treatment at all. And then at the end, you have the observations. So we classify group 1 in this pair as the experimental, then group 2 as the control. For this pair, group 3 and group 4, so we give the treatment to group 3 and no treatment for group 2. So we classify group 3 as experimental group for this pair and group 4 the control group. So take note on the diagram on where to give the control and where to have the experimental group. We have post-test only control group design. So we have random assignment. So we have group 1 and group 2. So still, you have to randomly assign participants to group 1 and then group 2. And then you give a treatment to group 1, no treatment for group 2. So experimental group, group 1, control group, group 2. And then finally, you are going to have the observations at the end. Then with subjects design, So we have group 1. So we have treatment and then treatment also. You subdivide group 1 into 2, treatment A and then treatment B. And then you have the observations for treatment A and the observations for treatment B. With a quasi-experimental design, randomness is not possible or practical, can control for all confounding variables. So these are the things that we are going to consider under quasi or quasi-experimental design. Randomness is not possible or not practical, can't control for all confounding variables. So non-randomized control group, pre-test, post-test design. Non-randomized control group, pre-test, post-test design. So we have group 1 and then group 2. So we have observations. So we have observations also. Then we have here treatment and then no treatment for group 2. So we have experimental group and then we have the control group. And then at the end, you give the observations. You conduct the observations. Then we have simple time series design. So we have group 1, so we have treatment, then observation. No treatment, then observation. Then treatment, then we have the observation. Then no treatment, and then we have the observation. So take note about this one. So reversal time series design. So you start with group 1, then treatment, then you undergo observation, then no treatment, then you do the observation, treatment, then you undergo observation, then no treatment at all, then you go observation or undergo observation. We have still under quasi or quasi-experimental design, alternating treatments design. So we have group one. So we have treatment A, then you have the observation, no treatment, then you have the observation. For treatment B, you're going to have the observation, then no treatment, and then you're going to have the observation. Then you have treatment A, then you have the observation, then no treatment, then you have the observation. Then you go to treatment B, and then you undergo observation. So take note about alternating treatments design. For multiple baseline design, so we have group one and then group two. So we have the baseline. So you have the baseline. You need to have the baseline information, meaning what you see before the conduct of the experiment. So we call the baseline information. And that's actually before the treatment. So if you don't know the baseline information, the baseline data, then it would be so difficult for you to have the treatment. So you start with group one. So no baseline information, then you do the observation, then you have there the treatment and then observation, then treatment and then observation. And then group two, so we have here no baseline information, you do the observation, then you have here no treatment, then observation, then you have treatment and then observation. So take note of that, multiple baseline design. We have single subject designs. No? Reversal time series, alternating treatments, and multiple baseline designs might also be used with either a single individual or a single intact group. So it can be a single individual or a single intact group. So for example, for one section or for one class, or maybe for a group composed of three. So you can have a single intact group. This approach is known as single case intervention research. So, ex post facto design. Researcher identifies events that have already occurred or conditions that are already present and collects data to investigate a possible relationship between these factors and subsequent characteristics or behaviors, often confused with correlational or experimental designs, not ex post facto, meaning the event had happened already. And you're going to find out the effects when that event had happened already. And it's never possible to have an experimental design, a true experimental design, or a quasi-experimental design, because having that experiment would actually have a damage or would have a critical effect to the participants. For example, if you're going to look at into effects of smoking, you could not conduct an experiment wherein experimental group you're going to let them smoke and then control group people would not smoke. So you could not actually do that. Why? Because if you're going to let the participants smoke, even if they actually have that waiver and the consent to participate in the experiment, but there might be damage that would happen to the participants. We know for a fact that smoking is actually have an adverse effects to people. But if you still conduct an experiment about the effects of smoking and find out a deeper analysis and understanding on the effects of smoking, then it would not be possible. Why? Because you could not get back the results. You could not actually say after smoking, you can get back whatever results that would happen to the participants. Then you are going to say, okay, there's a process of getting back all of those effects. So we could not do that. So we make use of ex post facto design. So we look at those different smokers and investigate what had happened in the past. We look at historical data about smoking. So that's why we call that one as collecting data after the event had happened. The ex post facto, after the event that had happened. So ex post facto design involves looking at existing circumstances like correlational research as clearly identifiable independent and dependent variables like experimental research. Involves no direct manipulation of the independent variable. The presumed cause has already occurred, no, unlike in experimental research design. So the presumed cause has already occurred. Like in the example that I mentioned, smoking is actually the presumed cause. So simple ex post facto design. So group one and then group two. Prior events. So we have here ex post facto, then in here, that there's no ex post facto. Investigation period, so we have the observations for group one and then group two. Two or more independent variables in a single study. So two-factor experimental design. So we have group one, group two, group three, and then group four. So we have random assignment. So it's a random assignment who will belong to group one, who will belong to group two, who will belong to group three, and who will belong to group four. And then we have treatments related to two variables may occur simultaneously or sequentially. So treatment related to variable one and treatment related to variable two. Then we have treatment one, we have treatment one, we have treatment two, but this one no treatment. And then we have treatment two, then no treatment in here. So if you notice group four and group three, no treatment for treatment related to variable one. And we have here, so treatment one, no treatment, then no treatment. Treatment related to variable two, so treatment two, then no treatment for group two, treatment two for group three, no treatment for group four. So alternating. Treatment, no treatment, treatment, no treatment for variable two. This one, treatment for variable one, treatment for variable one, then no treatment, then no treatment. And then at the end, you do the observations for the collection of the data. Factorial design. So combine experimental and ex post facto design. So it's a combination of experimental and ex post facto design. So we have groups, group one and group two. So we have prior events. So we have the ex post facto, we have ex post facto also. And we have the investigating period. So we have random assignment, we have random assignment. Group 1A, group 1B, then group 1, 2A, then group 2B. So group 1 is divided into A and B, then group 2 is divided into A and B also. Then we have the treatment for A, the treatment for B, the treatment for A, and then the treatment for B. And then you are going to undergo observations. So take note of this format. Meta-analysis. So it's a statistical technique, analysis of the analysis. Researcher combines results of many experimental and or ex post facto studies to determine whether they lead to consistent conclusions. So when you look at into different studies, and then you look at the analysis of those studies and you combine all of those analysis of the studies, interpretations and findings of those studies, and then have also an analysis of those different analyses, those different findings, those different interpretations and conclusions. Then you do meta-analysis. Conducting experiments on the internet. So some websites are set up to assist you keep ethics in mind. So ethical considerations must be always remembered. Remember, your sample will probably not be a representative. So all the time, although I mentioned that your sample must be representative of the population, but there might be some instances beyond the control of the researcher that your sample is not a representative of the total population. Acknowledging bias. Of course, even in the most controlled designs, variables may be ignored, sample may not be representative, task or setting may be artificial, identify it, acknowledge it, and report it. That's how you're going to acknowledge bias. identify the bias, acknowledge the bias, and then report the bias. So all of the topics, all of the ideas that I mentioned in this presentation are taken from Horizon Education Incorporated or rights reserved. If you want to borrow ideas, use the ideas presented by the authors in here, then always acknowledge the author of the book and Horizon Education Incorporated. So thank you very much.